Hello everyone, Mrs. Sedlick here. Welcome to your lecture for Friday, September 25th. I'm really sorry that I'm not there today. Hopefully I will be back next week. Unfortunately, my daughter was a little under the weather today, so I am home with her. You guys did a very good job on your Unit 1 test. I know that was a very long test, and I just want to say kudos to everybody. I could tell all the hard work and effort that went into doing well on that Unit 1 test. If you're unhappy with your Unit 1 test, we can definitely go back and do test corrections and you can raise your grade on that. Today's lesson, though, we're going to be getting started with Unit 2. I left a number of these note packets around, so hopefully everybody has a copy of this note packet. We're really going to only be going through the first page of this note packet. Not a lot of notes today because the point of today's lesson is to go over some fundamental skills that you really need for Unit 2. Let's go over what Unit 2 will look like. So we will have 3 sections on quadratic functions. So kind of factoring, I'm hoping this is something, some of this may be a review from Algebra 1, some of it will be very brand new. We will have 3 sections and then a mid-unit test. The mid-unit test will be very short, just 1 page, front and back. So it's a very short kind of catch up in the middle with the mid-unit test. Then we will have 3 sections after that, and a lot of the content from 2.4 and 2.5 is very new, probably not something that you will have seen in Algebra 1. So we're kind of starting to transition to a lot of the newer content that you'll see in Algebra 2. At the end of 2.6, we will have an end of unit test, and it will cover everything from 2.1 through 2.6. Today's learning targets, though, as we're starting to kind of get ready for Unit 2, we're going to simplify square roots and factor out the greatest common factor from algebraic expressions. Let us begin. So before we get to kind of our first learning target, which is simplifying square roots, I want to make sure we remember how to do a couple of important things like multiplying binomials. So your first example that you have in your notes is I have letter A where I'm multiplying negative 5x squared through this binomial. And normally, right, we would call this distribution. So I'm going to distribute the negative 5x squared through. First, when I multiply negative 5x squared times 7x, negative 5 times 7 is negative 35. And then x squared times x, I kind of pretend that it has a little 1 as the exponent there, and when you multiply with a common base, you keep the base and you add your exponents. So I get negative 35 x cubed for my first term, and then I just multiply the negative 5x squared by 1 minus 5x squared. So now I have multiplied through that binomial. Now the second question has 2 binomials being multiplied together, and you may remember, right, the 4-step process that we have to take with these types of questions. FOIL. FOIL stands for first, outer, inner, last. So the first part that I do is I multiply my firsts together. 3x times 2x is 6x squared. Then I multiply my outers, 3x times 5, and I'm just going to write this as one long addition statement. So I keep kind of adding the terms as I go through the FOIL process. Multiply negative 1 times 2x minus 2x. And lastly, negative 1 times 5 minus 5. Now I'm not done. I've got to go back and see, are there any like terms that I can combine together? I see I have these 2 terms that are common. They both are x's. So I can simplify this down to 6x squared plus 13x minus 5. Our letter C also asks us to FOIL, right? I've got 2 binomials side by side. So I multiply my first terms together. I get negative 2x squared. Then my outers, plus 8x. Then my inners, plus x. And then my lasts, minus 4. And again, I look to see if there's anything that I can combine with these, and I can combine the 8x and the x. So my final answer becomes negative 2x squared plus 9x minus 4. All right, time to get into what we remember about perfect squares. So what I would like you to fill out, pause the video right now, and go ahead and fill out all of these squares. So pick up your calculator or do them by memory, right? Hopefully some of these we have them memorized. But what I want you to do is make sure you're kind of filling in this table by yourself. So go ahead and pause the video and fill out all of these. All right, now that we have all of these filled in, I want to make sure we highlight which ones are the perfect squares, because you might see a question on a test that asks you for a perfect square. These numbers that we just filled in here, all of these are called perfect squares, okay? So perfect squares, and we'll talk about what the definition is. So all of these numbers that we just filled in are perfect squares. The way that we know that they are perfect squares, if you take the square root of a perfect square, you always get out a whole number. So nothing with a fraction, nothing with a decimal, nothing like that. We know it's a perfect square if when you take the square root of it, you get a whole number. So for instance, 36 is a perfect square because the square root of 36 is a whole number 6. Whereas 8 is not a perfect square. The square root of 8 is a decimal. It is not a whole number. So therefore 8 is not a perfect square. So make sure you kind of know the difference about what is a perfect square and what is not a perfect square. Let's get into our first learning target, which is all about simplifying square roots. So in order to simplify square roots, I have to pretend like no numbers exist except for these perfect squares. No other numbers in the world exist other than these perfect squares. So what I try to figure out is I look at a number and I say, okay, which one of my perfect squares divides into this number? And if there are a couple perfect squares that divide into the number, you always have to go with the biggest perfect square that divides into that number. So our first example here is I have 162. And I need to figure out, how do I simplify the square root of 162? On an ACT, they're never going to have non-simplified answers. Just like on an ACT, we would never see 10/15ths, right? They would always have 2/3 simplified down. So the same way we know how to simplify fractions, we also need to simplify square roots. And I know you've probably seen this before from other teachers. I'm just going to teach it the way that I've taught it over the years that really I think helps students the most. I don't do the trees, I don't do the branches. I stay with kind of the square root symbol that we're used to, and I use that throughout. So I think of 162 and I say, okay, I need to go back to my perfect squares and look at the closest number to 162. So the closest number to 162 is 144. And I ask myself, does 144 divide into 162? No. Does 121 divide into 162? No. Does 100 divide into 162? Nope. Does 81 divide into 162? And the answer to that is yes. So I know I found the perfect square I need to use. It is 81. So I rewrite 162. Notice how I'm keeping the square root symbol with me. I rewrite it as 81 times 2. Now I haven't changed the problem at all. All I did is I rewrote 162 as 81 times 2. Because of the rules of square roots and multiplication, I can break this out as two separate square roots. So I have the square root of 81 times the square root of 2. We know, right, the square root of 81 is 9, so the answer to this question is 9 square root of 2. On our next example, I've got 32, so I'm going to go back to my previous page and think of, okay, what perfect square divides into 32? Does 25? No. Does 16? Yes, it does. So I rewrite 32 as 16 times 2. Notice how it's still under the square root. I then break apart these into two separate square roots, square root of 16, square root of 2. And then last but not least, I can simplify my perfect square. I get 4 square root of 2. Moving on to letter C, what happens if we have a number out front? How are we going to treat that? Well, for right now, we're just going to have the -3 tag along for a ride. I'm still going to try to simplify the square root first. So I think about what perfect square divides into 18. The answer is 9. So I'm going to rewrite, notice how the -3 is coming along for the ride. I'm going to rewrite 18 as 9 times 2. Notice how I'm always putting my perfect square first. The reason why I write my perfect square first is because I know that perfect square is going to be able to come out of the radical. So I kind of like to keep things in that order so I don't get confused about where I put the 2. I then break apart my 9 times 2 under the radical, so I have the square root of 9, square root of 2. Notice how there is no addition symbol anywhere within this statement. Up here, I am multiplying -3 times the square root of 18. Down here, I am multiplying -3 times the square root of 9 times the square root of 2. Oftentimes, students will just pull plus signs out of thin air and stick them in here, and that is not the case. We are multiplying these things together. I take the square root of 9, it's 3. I now know I just have to perform this operation, this multiplication, and I have simplified this down to -9 square root of 2. Last but not least, we have this one here, right? I'm going to keep the 6 along for the ride. If you'd like to pause and try this on your own before I do it, go right ahead. I'm going to break this apart into its perfect squares. Now, some of you may see 12 and think 6 times 2. But 6 and 2 are not perfect squares. The only numbers I care about are the perfect squares. So I've got to go with 4 times 3. Break apart, square root of 4, square root of 3. Keep going down the line. The square root of 4 is 2. Multiply my outsides here, and I wind up with my final answer, 12 square root of 3. At this point, I highly recommend you pause this and complete the IXL, which is all about simplifying square roots. The link is on Google Classroom. Now we move on to just the last couple. We're going to get to 4, 5, and 6 in your notes, and that will be it for our note taking for the day. Now this whole unit is going to be all about quadratic functions. Last unit was all about linear equations. Now we're going to start talking about quadratic functions. So a quadratic function is whenever you see an x squared. So if your biggest exponent is an x squared, not an x cubed, not an x to the fourth, but an x squared, then you have a quadratic function. And quadratic functions make a parabola shape. This may or may not be something you have heard before. A parabola shape is a U shape, and it can be either going up or going down. So eventually we will get to the point where we will start working more with a quadratic and graphing it and all that fun stuff. But I first wanted to make sure I pointed this out because as we go through this unit, there will be a lot of x squareds in our examples that we will be going through. Now on to our second learning target, which is factoring out the greatest common factor. So I not only have to figure out what the greatest common factor is, but I have to divide it out of the problem to see what is left over. And hopefully as I go through an example, you'll understand what I mean by factor it out, divide it out. So in example A, I see I have 14x squared y cubed plus 7x squared xy squared. So I have to figure out, I have two terms here, what is common in both this term and this term. So the first thing I do is I think, okay, what's my GCF of 14 and 7? What number divides into both of those? Well, it's 7. So I'm going to bring a 7 out. Then I think about, all right, I have x squared here, which is x times x, and I just have x over here. No x squared, no x cubed. So because this one has two x's and this one only has one x, the thing that is common between the two is just one x. So I'm going to factor that out. Then I look at my y's. This term has 3 y's. This term has 2 y's. I always go with the lower exponent. So the greatest common factor between these two terms is 7xy squared. When you were in Algebra 1, that may have been where you stopped, but we are going to keep going, meaning I want to rewrite this expression with 7xy squared factored out of it. I've got to fill in kind of what is left over within the expression once I divide out my greatest common factor, 7xy squared. You may want to kind of do the division on the side. So if I have 14x squared y cubed, that was my first term, and I'm dividing out 7xy squared, that division, so 14 divided by 7 is 2. X squared divided by x is x. Y cubed divided by y squared is y. So I'm left with 2xy in my first term, and then in my second term, oh, look at my second term. My second term is 7xy squared, and my GCF is also 7xy squared. So what does this number represent? When your numerator and your denominator are the same, you're just left with the number 1. And that placeholder of plus 1 becomes extremely important. If you forget that placeholder, you don't have the exact same expression. I started with this one up here. I've ended with the same one. It's just written differently. And if you want to check your work, in order to check your work, you distribute this back through. And when you distribute, you should wind up where you started. Right, let's move on to our second example. I have a couple of negatives, right? Negative 4z to the fourth minus 16z to the third. What is common between these two is a negative 4. So I'm going to factor out a negative 4. This term has 4z's. This term has 3z's. So I'm going to take out the lowest exponent, which is z cubed. And I have to see what is left over with the terms that I have left. So you may want to do that division, or you may be already doing this in your head, which is totally fine by me. You do not have to show all of this work. And actually, the more you practice this, the less work you'll have to show. But I at least want to show you where I get the numbers. All I'm doing is I'm dividing this GCF out of this expression. So I'm going to look at the first term in my expression, negative 4z to the fourth, and since I'm dividing out negative 4z cubed, I can see what I have left over. Well, my negative 4's cancel out. Those are just a 1. And then z to the fourth divided by z cubed, it means I have a z left over. Same thing for my next term, negative 16z cubed, negative 4z cubed. So I have to see, all right, what is left over here? Well, negative 16 divided by negative 4 is a positive 4. And my z, since I have both a z cubed in my numerator and denominator, those cancel out and just equal 1. So this is my answer. And if I want to check again, remember, if you're trying to check, which is always a good strategy, all you have to do is distribute back through and make sure you wind up where you started. All right, our last example, when I look at these three terms, the number that sticks out to me that I know is divisible in all three of these numbers is 25. This first term has 4 n's. This term, 3 n's. This term, only 1 n. So the only thing that's common between all three is just the 1 n. So I factor out my greatest common factor, which is 25n, and I need to figure out what is left over. So 25 times 6 would get me back to 150. And since I factored out an n, but I need 4 of them, I must have 3 n's left over for that term. Next, 75 divided by 25 is 3. I have n cubed here, and I factored out an n, so I have n squared. And then last but not least, this 25n is the exact same thing as my GCF, so that tells me all I need left is the placeholder of the plus 1. And again, if I wanted to check, right, all I would need to do is distribute back through and go ahead and verify that I wound up where I started. At this point, I would like you to pause as well and complete the IXL all about factoring out a monomial on IXL. Although, to be honest, we are really done with the notes for the day. That was it. That was all I wanted to cover today. These are fundamental skills that we will need in order to be successful in Unit 2. You have 2 worksheets, I know, 2 worksheets that you need to complete on these 2 topics, and those will be due on our next class, which will be Tuesday. Hopefully I will be back in on Monday. You never know, right, with everything going on, but hopefully I will be there. Otherwise, I can always be reached by email if you have any questions. Thanks, guys, and have a great weekend.